Now we're going to look at the prehistory of the Great Plains, and we're going to start long before humans were present in the area. The area that today is the Great Plains, 145 million years ago, was underwater. It was submerged beneath the western inland sea, all the way from north to south, as you can see here in this map. A lot of the flatter areas, the lower elevation areas, were the ones that were covered with water, and the life forms that were there were aquatic life forms at that time, including various types of aquatic, perhaps dinosaurs, but also sharks, which to the right, I think that's in Kansas, that's rock formations that you can find on the plains that have that distinctive look to them, that are actually the result of sediment building up on the sea floor over millions of years ago when it was a sea. Now, if you'll notice on the map, over on the left, to the far west, you've got essentially Arizona, Nevada, Idaho, Washington, Oregon, California, Baja, Mexico. That was all above sea level, and there's a picture of a Tyrannosaurus Rex there. That's because Tyrannosaurus Rex, well, was there, but actually that's the native area of the Tyrannosaurus Rex. There were a couple of other types of tyrannosaurs in Asia, but so far as we know, Tyrannosaurus Rex was specifically a Western American phenomenon. All the fossils that have been found in that area. But so far as the whole plains being submerged under the sea for a long time, right? 40 to 89, almost 90 million years, up to 66 million years ago, explains why today sometimes we see headlines like this. The fossilized remains, fossilized teeth of sharks, giant sharks in Kansas. Well, about 65 million years ago, the sea receded, and that area was then covered with forest, a forest biome, an environment, essentially. And the forest covered the Great Plains for about 40 million years after that, but due to climatological changes that took place, due to things getting drier, then that forest receded, even as the sea had receded. And circa 25 million years ago, you saw the beginning of a grassland biome in the Great Plains, which is what is still there. Well, going forward from there, the Pleistocene era began about 2.6 million years ago and lasted until 11,500 years ago, or circa 9,500 BCE, followed by the Holocene era, which is the era that we're in, the era of modern humans. During the Pleistocene era, toward the end of it, there was a great ice age. Actually, there were cyclical ice ages, and we'll talk about why that is in a minute. But roughly, they would go through these cycles where you would have an ice age for about roughly 100,000 years. So in this case, we're talking about roughly 114,000 years ago, an ice age began and lasted a little over 100,000 years. About 20,000 years ago, or about 18,000 BCE, things started to warm up and the ice started to melt. Then, circa 10,800, circa 11,000 or so BCE, the warming stopped. It got a little bit cooler. This is known as the Younger Dryas period. So there was a cooling spell, then another warming spell about 2,000 or 3,000 years later that lasted 4,000 years. This is known as the Altithermal period. So that by about 4,000 years ago, for a couple of thousand years, you had very, very mild temperatures in the northern hemisphere. So this is a lot of swinging back and forth. The Ice Age, the last Ice Age in particular, at its high point, the ice was about 1 mile thick. And here on the left is a picture of the areas that were covered in ice during that time, looking at the globe from the top, looking down at the North Pole. So there's Greenland and Iceland. There's large portions of northern Europe and Asia over in North America, all of Canada, down into the northern parts of what is now the United States were covered with these thick, thick sheets of ice. And on the right, I have these pictures of Europe, just in case you're curious what was going on over there. It's kind of hard to tell on this map on the left because Europe's upside down, but you can see what's going on there. So that's when the ice was at its thickest, and then it began to melt as the Ice Age was winding down. Astronomers can explain those Ice Age cycles via a phenomenon known as Milankovitch cycles. And what this pertains to is the Earth traveling around the sun, both the Earth's orbit around the sun and also the way the Earth tilts on its axis, which it's spinning, of course, on its axis. Now, generally speaking, Earth's orbit is kind of circular, almost maybe a little elliptical, but at certain periods, or for about 100,000 years out of every 400,000 year cycle, that orbit kind of gets stretched out, so it's much more elliptical. It's a much thinner oval. And as that is happening, there are also eccentricities in the tilt of the Earth's axis. It kind of like goes back and forth by just about 3 degrees. It sort of very, very slowly wobbles. And those two things put together are what results in, for about 100,000 years out of every 413 year cycle, like I said, a period when the amount of solar radiation reaching the Earth is changed from what it is at the other 3/4 of the time, and that results in much colder temperatures and results in an ice age. And so it just sort of like repeats about 100,000 years, and then it gets warmer as that orbit kind of comes back into the quote norm, 75% norm for it. And then that ice will melt, and about 300,000 years will go by, and it'll all start all over again. Just if you could imagine, there's a picture here, the upper right-hand corner of that Milankovitch cycle image of a top, a spinning top. So if you could just imagine a top spinning around and around, and it's kind of wobbling, right, as it spins, but it also moves in sort of in a circle as it spins, and that's what the Earth is doing, and that's why you have these ice ages. Now, by the way, in addition to teaching American Indian Studies courses, I also teach environmental history, and I'm sure that some people watching this after that discussion of Milankovitch cycles and ice ages being sort of cyclical probably are, some of you may be saying to yourselves, well, if this is just kind of a cycle with the Earth getting warmer and colder because of the Earth's orbit and axis and so forth, what's all this talk then about global warming and climate change caused by humans? Isn't it just instead a natural cycle? Well, no, because that warming is thousands and thousands and thousands of years sooner than would happen in those natural cycles. Okay, and it started getting much warmer than it ordinarily would right around the time of the Industrial Revolution, when carbon-based pollutants started being spewed into the atmosphere and just mushroomed in the 20th and into the 21st century. So take my environmental history course if you want to learn more about that. But short answer, this theory explains why there are ice ages every so often, but does not explain the global warming that is going on right now on the Earth. That's different man-made factors going on there. All right, well, we've talked about the geographic prehistory of the Great Plains and really of North America in general. Now let's put some people in it. So here's an interesting map about human migration. It's generally considered that Homo sapiens, modern human beings, developed in southern Africa somewhere around 200,000 or 300,000 years ago. And that's where they stayed for most of their existence, for at least a couple of 100,000 years. But somewhere between 60 to 100,000 years ago, KYA, 1,000 years ago, they started moving northward and spreading out around throughout Africa. Then somewhere around 50,000 years ago, they developed speech. 50 to 60,000 years ago, a group that was concentrated in northeastern Africa crossed over into Asia Minor, also known as the Levant, today area that we think of as the Middle East. And from there, spread out all throughout Europe and Asia and even down into New Zealand and Australia via traveling from island to island by canoe until eventually reaching those areas. Now, this map has this color coding, and it says there, you'll notice source of founder effect. This is from an article, an academic journal article about the founder effect, which we're not, it's a little too complex for us really to go into much, but just to let you know what it is. It's the idea that when humans started traveling, when they would sort of congregate over time, gather and concentrate into one area, like, for example, when the first humans from that orange area in southern Africa moved up, they were all around Africa, but moved up into the yellow part. There's a lot of people concentrated there, and groups of those people then spread out into smaller groups to found sort of new colonies, new populations in other places. And the founder effect basically just says that with each one of these, every time one smaller group breaks off from the larger group and goes off sort of on their own to found a new population, there will be less genetic diversity in that group than from the larger group they came from, because there's a narrower gene pool. And then that leads to some slightly different physical characteristics among different kinds of people. Now, you'll notice that the crossing over into North America happens much later than, say, for example, into Australia, about 15,000 years ago. And once that happens, then, you know, it's gradually a population of North and South America. So let's take a look at that situation and the best of our knowledge as to how and why that happened. Remember our earlier map and the fact that during the Ice Age, that mile-thick layer of ice covered a good part of the northern hemisphere, all the way down, covering all of Canada, down into the northern part of what is today the continental United States. But it didn't quite reach all of Alaska. The westernmost part of Alaska was not covered in ice. So there was between Asia and Alaska what is sometimes called a land bridge. All right. Now, it wasn't actually a literal bridge. It was an expanse of land that was exposed at that time because at that time the sea levels were lower. So looking at this map, you can see the yellow areas. That is these places as we know them now. But sort of the gray, the dark gray that surrounds the yellow, that's the areas that before the ice started melting were not covered by water. So they kind of jutted up out of the water, and it was all connected. So Alaska was physically connected to the easternmost tip of Asia there in Siberia. So the people who moved into that area eventually, into that part of Asia, were able to just walk across into Alaska. They couldn't walk any further, though, because then they reached those glaciers. So for quite some time, human beings were sort of bottlenecked up there in western Alaska. But 20,000 years ago, when things started to warm up and the ice started to melt, this corridor developed right down there through western Canada. And it developed because that's kind of how melting ice works. You've seen it yourself, no doubt, when there's ice on your window and it gets warmer, the sun comes out and it starts melting. It melts in rivulets. So that big corridor was kind of a rivulet of melted ice. So for a long time, the predominant theory of how humans migrated to the Americas was that first they had walked across that land bridge, and then from there, what is now the Bering Strait, then from there, when that ice-free corridor opened up, then animals started wandering down into Canada in that corridor, and hunters started following them, and over time made their way farther south until they reached the ice-free area of what is now the United States, and then from there, their descendants traveled further southward, populating North and South America. So that theory was first introduced about 100 years ago. And like I said, it was the dominant theory for a long time, for pretty much the rest of the 20th century, maybe even into the early 21st century. But since then, there has been another theory that has taken hold, probably more, that's more accepted now than the whole coming down the ice-free corridor. And that is the idea that people from Alaska, who were closely related to the people in Siberia, at one time the same people, traveled by boat along the coast there, up in the Northeast, along that coast there of ice, not really knowing how far the ice went, but eventually coming to the end of the ice and making landfall. And so that perhaps they were able then to travel along the coast in their sort of basic boats all the way down to the tip of South America, much faster than if they had been, walking there over the generations. And that idea is actually gained traction due to the fact that in recent decades, archaeologists have discovered evidence of human habitation right around in this area, south of that glacier, evidence of human habitation before the ice started melting and before that corridor opened up. So that sailing along the coast makes more sense as to how people could have gotten that far south before there was a way to walk there on foot. My personal belief is that probably it was both. There were probably people sailing along the coast, and as this ice-free corridor opened up, people probably came down through there as well. But be that as it may, either way, over time, populations increased, and we're talking about thousands of years, until all the way as far south as the tip of South America and Tierra del Fuego was populated. Now here is another map to show you that land bridge, just to demonstrate that it wasn't a narrow little bridge. It was a huge area, and how easily it would have been for people to have walked across there, but also how easily it would have been, as you can see, traveling along these islands, to then travel along the coast. Which brings us to the fascinating story of the Athabascans and the Ket people of Siberia. Now, Athabascan is a language group. There are several different large language groups of native peoples in North America that we'll talk about a little bit more later. The Athabascans in particular include groups like in Alaska, groups such as the Yupik, which are right there in western Alaska. Other Athabascan languages, you can see here in the map on the upper right, all down through actually northwestern Canada, there are groups of Athabascans, Athabascan-speaking tribes, and way down in the south, there's some of the Pacific Northwest, some small enclaves, but there's a bunch down there in the southwestern part of the United States. That's the Navajo and Apache peoples speak Athabascan languages. They are relatively recent arrivals to the desert Southwest compared to the Puebloan peoples. They migrated there sometime within the last several centuries. But the Athabascan people, the Athabascan language group, researchers have discovered in the last few years a very remote group of Siberian people called the Ket that are very isolated and very not very populous, and not very many native speakers of their language left. But it does still exist, and it has a lot of similarities, apparently, to the Athabascan languages. And a few years ago, it was further discovered with genetic research that the Athabascan peoples of North America, such as the Navajo, have more genetic markers, genetic material in common with Siberians than do other Native American tribes and groups. So that sort of lends some credence to the idea that the Athabascans are a little bit more closer in time to their ancestors who migrated from Siberia. Now, the whole thing didn't happen. Everyone didn't migrate at once. It was in waves over centuries, even millennia. So it's entirely possible that one of the most recent, one of the final migrations, maybe like 5,000 years or so ago, resulted in the arrival of the Athabascan people, and that would help explain these various similarities. I don't think that it can be conclusively proven one way or the other, but it is really fascinating to think about. All right, well, once that ice age was well and good over, and the ice started to melt, of course that ice has to go somewhere. It turns into to water and goes into the ocean, and that makes the ocean levels rise. So we looked at that previous map that showed all those dark areas that had previously been exposed above sea level, had been dry land, that now are submerged. Well, with all that mile of glacier melted, the sea levels around the world rose by about 400 feet So that wound up, of course, covering some of those lower elevations, and that included, as you look in the upper left-hand corner there, part of that land bridge that had existed for so long, so that now there was sea between Alaska and Siberia. So that is the current prevailing theory and explanation for the peopling of North America. And those earliest people who did arrive in North America made their way, whether it was on foot or in canoes along the coast or whatever, made their way into the present-day United States and Central and South America. Those people are known as the Paleo Indians, the Stone Age Indians who were the ancestors of the various tribes and nations that would later develop. So we are now at the era of prehistoric human habitation in the plains and in North America in general. So that's what we will talk about next.